Hello guys, in this video we are going to be explaining linear equations, and for the SAT math prep that we're going to do on this channel, this is the first lesson of that series. So we can begin by explaining what is a linear equation. A linear equation is an equation that describes a straight line on a graph. So these two graphs represent linear equations. We can even read the graphs and say, so this is of course x and the horizontal is y. So we can say y equals -3 over 5x plus 2. This is the equation of this graph, while this one is y equals 2x. We will explain how to read graphs later on in this video, but these are just the examples of the equations. Some more examples include y equals 4x minus 1, y equals 1 over 2x, and yeah, these all are examples of linear equations. So as we can tell by all these examples, linear equations have to have one thing in common, which is the degree can't be greater than 1. What is the degree? The degree is the power of the unknown variable. So here, the unknown variables are x, and all of them are to the power 1. When an unknown variable doesn't have any number on top, that means it's to the power 1. So these all don't have any greater exponent than 1, meaning they're all linear equations. So if I were to say y equals x squared minus 2, this would not be considered as a linear equation. Now, all linear equations have a slope, and you may be asking, what is a slope? So a slope is the rate of change of an equation, or its rise over run. So what does rate of change mean? Let's take an example where y equals 4x. Rate of change, every time there's a change in x, the unknown variable, there's a constant that changes every time. So let's say x was 1. So 4 times 1 would be equal to 4. And then the change happens when x becomes, let's say, 2. So 4 times 2 is 8. And here, the change that happened was 4, meaning that 4 is the rate of change, or the slope. So 4 is the slope. Another example would be y equals 3x minus 2. Here the rate of change is stated directly by x. This is the slope, or the rate of change. There can be situations where there is a number by y, and it's not simplified in this perfect form where we can directly find the slope. In this situation, we would have to manipulate the equation so it can be in this form. I'll explain it now. Let's say we had 1 plus 2y equals 4x minus 2. Now we're going to have to manipulate the equation so we can have y alone. So we'll keep 2y, move 1 to the other side, making this 4x minus 2 minus y. So 2y equals 4x. This can be simplified to -3. And then we will divide by 2 on each side to get y alone, making y equals 4 over 2 is 2x, and we can keep this as a fraction, 3 over 2. So the slope here is this number, 2. And this is the method we use to find slopes for equations directly. However, sometimes you might need to find the slope from a graph. This is where the term rise over run becomes very useful. So in this graph here, the equation is y over 2x. So we knew directly that the slope is 2, but how could we tell this if we did not have this equation? We will use the rise over run method. So let's check how much this rose in the y-axis in comparison to the x-axis. So it rose by 1, 2, and then the run was 1. So we can say 2 over 1, which simplifies to 2, which is correct, like we mentioned. This is the slope. So you'll just check how much any points, 2 points, change. So this rise was 2, 1. Again, here's a point, here's a point. We can say rise was 2, and the run was 1. So we could directly identify the slope from the rise over run, which proved to be correct in the equation, which was 2. So we already talked a bit about determining the slope from the graph, but there is something really important to know while solving these types of questions. So like we mentioned before, we find the rise over run of a graph to be able to determine the slope. But the direction of the rise or the run is extremely important to determine the sign of the slope. What do I mean by this? I mean that if the rise means if the number that it rises is going upwards, then it's positive. But if the number is going down, it's negative. And the run, if it's going to the right, then it's positive. But if it's going to the left, then it's negative. Now, this might be confusing right now, but let's do these 3 examples to further understand this point. Now let's take these 2 points from this graph, and we'll check the rise. So 1, 2, 3. 3 going down, so it's negative 3. And then 1, 2. 2 to the right, so it's positive 2. Negative 3 over 2 is the slope of this graph. So if I said 3 over 2 is the slope, that would be incorrect. We have to put the accurate sign of the slope. So that is incorrect. So here's the slope of this one. Now for the second one, 1, 2, 3, 4. 4 upwards, so positive 4. And then 1, 2 to the left, so negative 2, making this slope negative 2. And now for the last one, here's 1 point, and here's another. Determine the rise is 1, 2, 3. 3 going up, so we can say positive 3. And the run was 1 to the right, so positive 1, making the slope 3. The sign of the slope is now accurate for every answer, and we can be sure of our answers. Now, if we analyze the results of these questions, we can realize that negative slopes on a graph appear to look like this. So while x increases, the graph goes down. And when it's positive, the slope will look something like this. While x increases, the graph goes up. So this is a really good rule to know, or idea or concept to understand while checking slopes. So say the question was asking for the number or the slope specifically, but if it was a positive or negative slope, or if it was increasing or decreasing. Just by looking at this, we can say that it's decreasing because it's going down as x increases. This one is also decreasing. This one is increasing. So this is a really good way to figure out the sign of the slope just by looking at the graph. Now we will solve some slope practice questions. Feel free to pause the video and solve them yourself, and then try to check the solutions that we will solve now. So for the first question, try not to get confused and just assume 4 is the slope because it's by x. Because here y has a number, so we have to simplify it to make sure it's in this form where y is alone, so we can directly take the slope. So since 2y is on one side, all we have to do is divide by 2 everywhere to make sure we get y alone. Y equals 4 divided by 2, that's 2x, negative 8 divided by 2 minus 4. So 2 here is the slope. In this question we have to simplify, so we'll start by distributing 6y by y, 6y, 6y, negative 12 equals 5 plus 2 multiplied by 2x, that's 4x, 2 multiplied by negative 3, that's negative 6. Now we will take negative 12 to the other side, making 6y equal to 5 plus 4x minus 6 plus 12. Now to simplify, we will take 6y equal to 5 minus 6, that's minus 1. Minus 1 plus 12, that will be equal to 11. So we will say 6y equals 4x plus 11. And to get the y alone, we'll divide by 6, divide by 6, divide by 6. Y is equal to 4 over 6, and we simplify to 2 over 3x. We can keep this as 11 over 6. So the slope is 2 over 3. And now for the last question, we're going to identify the slope from the graph directly, meaning we will use the rise over run. And let's find 2 points to check. So here's a point. And now we can count the rise 1, 2, 3. And because it's going down, we're going to say -3. And then to the right, it's positive. So 3, 1, 2, 3, 4, 5. To the right, positive 5. -3 over positive 5. This is the slope of the question. Okay, now I'm going to be discussing the y-intercept. Linear equations have y-intercepts, which basically mean the point where the function or the linear equation intercepts the y-axis on the graph. So this might be hard to understand now, but with examples it'll be clear. So let's begin with saying y is equal to 3x plus 2. Here the y-intercept is 2. How could we tell? Because it's the constant of the equation where there was nothing by y, and it was stated directly. This was possible to find directly because it was in the form y equals mx plus b. B will always be the y-intercept in this form. Well, let's say we had 2y equals 4x minus 3. You may say, okay, -3 is the y-intercept. However, that's not true because there is a number by y. First, we have to simplify by saying divide by 2. Y equals 2x minus 3 over 2. 3 over 2 is the y-intercept. Now, this is easy to find from equations. What does this mean? What is the y-intercept? If x were equal to 0, so in this equation, y equals 2x, let's make it 0, -3 over 2. This will simplify to 2 minus 2 times 0 is 0, -3 over 2. So y would be equal to -3 over 2. This is shown in the graph, let's say. This was -3 over 2. Okay, the linear equation will intercept the y-axis at that point. That is the y-intercept. And we explained how to find them from equations, and from the graph we can look directly at where the line crosses the y-axis and figure out where the y-intercept is. Now, just to make sure that we understood the y-intercept, we're going to solve these practice questions real quick. So the first being y equals 6x minus 20, and here the question wants us to find the y-intercept of this equation. So just by looking at it, I can see that it's in this form, y equals mx plus b, where there's nothing by y, meaning that b is the y-intercept. So -20 here is the y-intercept. In this question, we see that the equation isn't in this form. So we'll just manipulate it to have nothing by y to be able to find the y-intercept. So take this to the other side. -4y equals, so -3, -2x, it's -5x plus 5. And we're going to divide by -4 everywhere to get y alone. Y is equal to 5 over 4x and -5 over 4. This right here is the y-intercept. And now for the graphs, we will first determine where the point, let me do this in black, where the point, the function intercepts the y-axis, right? We said that's the y-intercept. So the point where it intercepts the axis is at this point, where we can see is 1, 2, 3. Y-intercept here is 3. And for this one, we can see that the function intercepts the y-axis here at -2. So the y-intercept is -2. A very common question on this lesson, linear equations, and especially on the SAT for linear equations, is to find the slope from 2 points, where they give you 2 points on a linear equation, let's say 2 and 3, and say 0, -5. And they ask you to find the slope from these 2 points. Now, from our information on the slope, we know that the slope is the rise over run. So we need to find the rise over run. rise is on the y, and the run is on the x, correct? And since we know this point is, say, x1, y1, and this is x2, y2, we can find a rise from these two and a run from these two. So this formula, rise over run, is the same as saying y2 minus y1 to find a rise, and x2 minus x1 to find the run. And now we'll just fill in the equation with our numbers. So y2 here is -5 minus y1, which is 3, over the run x2 0 minus x1, which is 2. So here's -a over -2, which simplifies to 4. So the slope of this equation is 4. Now we can take a practice question. 1, 8, and -4, 2. Again, we're going to use the rise over run, which is y2 minus y1. It's best to memorize this equation, especially if you're going into the SAT. Minus x over 2. So let's put our points. This is x1, y1, x2, y2. So y2 is 2 minus y1 is 8 over x2 is -4 minus y1 -1. So this is equal to -6 over -5, making 6 over 5 the slope. And now let's quickly discuss the forms of linear equations. This is honestly really good to know to figure out when they ask you certain questions where you need to find certain things on a linear equation. So it's good to manipulate the equation to these three forms to find certain things. So we will discuss them now. The slope-intercept is the y equals mx plus b equation that we talked a lot about. This is super useful because it directly gives you the slope of the equation and the y-intercept of the equation. The point slope formula is useful when, so let's write it first, y2 minus y1 equals m x2 minus x1. This is super useful if they ask you to find points from the slope, where you can manipulate it to this form and find 2 y's, 2 x's, and the slope. If you recognize, this is the formula we were using before to find the slope, y2 minus y1 over x2 minus x1 to directly find the slope, but they manipulated it in this way to be able to find the points and the slope directly. And lastly is the standard, which is, let's say, ax plus by equals c. Here we can't directly find anything. We can't directly find the y-intercept or the slope because everything has a number next to it, and this may not be simplified. They give you the question, they probably will give it to you in this standard form. Then you can manipulate it to the slope-intercept or the point form and solve for whatever question they give you on that form. But it's really good to know these three forms and how they're useful. Now, this type of question on this lesson is extremely common on the SAT, and it is where they'll ask you, how many solutions does the system of linear equations have? So you're probably like, hold up, what is the system of linear equations? What do you mean by how many solutions? We'll explain all of this now. So let's start with system of linear equations. That's when they give you, let's say, 2 linear equations, and they want to see how many solutions are in between them. So how can we tell how many solutions? This is easily done by equation or by graph. So I'm first going to explain the concept by using graphs. So let's say, here's a graph. They gave you one linear equation that gave us this function, let's call it f of x, and another function which was, let's say, g of x that went like this. A solution is a point where they intersect. So this right here is the solution of the equation. We could find it by you know, if there was numbers, we could figure it out, or if we had the equations, we would be able to specify. But this linear equation, system of linear equations, has one solution, because right here there is one dot where they intersect, or one point where they intersect. This will have one solution. Now let's say there's 3 scenarios, so this is just one of the scenarios. Now let's say we will use f of x and g of x again. Let's say we had another graph and they gave us this for the first equation, again f of x, and this, don't worry about the names, honestly, this is just the name of the linear equation, g of x. And they're like, how many solutions are in between them? Now these 2 lines are parallel, like let's pretend I drew them perfectly, and these 2 are parallel, meaning they will never intersect, meaning there are no solutions. So for this system, there are no solutions. Lastly, the last case is infinite solutions. So this can happen when we have a graph and they give us f of x here and g of x. Pretend I drew the same line. Oh my god. Okay, this is as perfect as it gets, okay? And this is gx. So these 2 are the exact same line. They have the same slope, same y-intercept. It's exactly the same. So when they gave us these 2, we can say, yeah, well, they're infinite solutions because it's intersecting the whole way around. So this system of linear equations has infinite solutions. And on graphs, we can determine, like based on the numbers, we can determine where exactly do they meet. For this, we're going to say infinite, the other one none, but if it was like 2, we can just figure out the number directly from the graph. But sometimes they won't ask this question on graph. Most of the time it's by equation. So we're going to discuss questions on each one and how to solve them. Okay, so here is the first example. They gave us a system of linear equations and the question is, how many solutions are there for x? Right, so how many solutions are in between them? How many solutions are there for x? Same type of question, same idea, and same approach. So we're going to start by finding the value of y and substituting it in the second equation. That way we can find the x's to simplify it and get a value for x, or not, or get infinite. So we're going to see which case this is. So since y is already perfectly simplified here, we don't even have to bother simplifying. We're just going to substitute it directly in the second equation. So this said 3y, and since y is x plus 1, we write that as that equals, and then we're going to continue negative 3x plus 9. And we'll substitute 3 inside. That's 3x plus 3 equals negative 3x plus 9. Now we will take this 3 to the other side, get x's together, this to the other side. So 3 plus 3x, that's 6x, equals 9 minus 3, that's equal to 6. So if we simplify these, divide by 6 on both sides, x is equal to 1. So here we have one solution. Now on to the second example. We have another system of equations and we're going to try to figure out how many solutions there are. So since there isn't any simplified y, I'm going to just take this equation and simplify the y. So here it is. We're going to take x to the other side, making 2y equal to negative x plus 4, divide by 2. Y is equal to negative 1 over 2x. That's 4 divided by 2 equals 2. This is the first equation. Now we can substitute this into y over here. So 2x plus 4, y was negative 1 over 2x plus 2, and then equals 2h from the original equation. Now that we have this, we can distribute and simplify. So 2x equals now 4 inside this. This will be negative 4 divided by 2. That's negative 2, and there's the x. And 4 multiplied by 2, that's positive 8, equals 8. And now we'll take this to the other side and simplify. So 2x minus 2x, that's 0x, equals 8. If this to the other side would be negative 8, again 0. So 0x equal to 0. This is 0x equal to 0. This is infinite. This has infinite solutions because whatever we put for x will always be equal to 0. So if x were, if x were 1, 1 times 0, that's 0. If x were 10, 10 times 0 equal to 0. Any number we substitute for x will always equal 0, meaning this will always be true. So that means there are infinite solutions to this question. Infinite solutions, or infinitely many solutions. Now on to the last question. We are going to simplify again one of the system of equations. And now on to the last question. So again, we're going to try to get y alone and substitute it, the whole equation for y, into the second equation. So let's say 6x plus 4y equal to 8. Take 6x to the other side, 4y equal to 8 minus 6x. Now we're going to try to get y alone, so divide by 4 everywhere, making y equal to x divided by 4, that's 2. Negative 6 over 4, that's 3 over 2x. So here is the solution for y. Now we're going to substitute this equation into the second one. So 3x plus 2y. Here we have the value of y, so we're just going to put in 2 minus 3 over 2x equal to 5, based on this, right? Now we're just going to simplify. 3x we distribute in the 2, so that's 4. That's negative 6 divided by 2, that's negative 3x equal to 5. Now we're going to get 4 to the other side. 3x minus 3x, that's 0x, equal to 5 minus 4x, that's going to be 1. Now, 0x is equal to 1. Some people might assume, okay, infinite solutions because we found 0x, but that's not true in this situation. That will only work if 0x is equal to 0. However, 0x equal to anything else will make there be no solutions, because whatever we substitute into x will always be 0. And if 0 is not equal to 0, they put it, like here in this situation was 1, that's just simply not true. 0 isn't equal to 1. So there are no solutions. So whatever you simplified, say we put 2 in x location. 2 times 0 is 0, 0 is equals 1, that can never work. So this equation has no solutions. So quick final revision on this part when we talked about 1, none, or infinite solutions. 1 was when we solved and we found a value for x, so say 2. So x equals 2, yes, we have a solution. None was when we had 0 multiplied by x equals to anything other than 0. So let's also say here 2. This can never be true because this will always be 0 and this will always be 0 and this will never be 0, so no solutions. And infinite solutions is again when we had 0 multiplied by x, but this was equal to 0. Whatever x is will always be equal to 0, so this will always be true. And on the graph, we can revise each type. 1 is when they intersected at a point. There is one solution. None is when they were parallel and they never intersected, meaning there are no solutions. And infinite when they were both the same line, meaning they intersected at every point. Okay, so another really common question on the SAT is on this lesson is when they give you a question asking about which linear equation is parallel to, and then they give you a linear equation. So here say y equals 3x minus 6. And then they'll give you a bunch of equations and you're going to see which one is parallel to the one they specified. However, how could we figure out if it's parallel or not? So to have a parallel line, we need to make sure the slopes are the same. Slopes are the same. This is the first thing we need to check. So like on a graph, say we have two parallel lines, these slopes here are the same, so they never intercept, because if there's even a small difference, they're going to eventually meet somewhere on the plane. So having the slopes being the same is super important to be parallel. However, a really important distinction is that we can have the slopes being the same, but they would be the same line as well. So how the distinction here is that this and this have different y-intercepts. However, these two have the same y-intercept. So this is parallel because the slopes are the same and the y-intercepts are different. Y-intercepts are different. So if these two rules apply, then these two lines are parallel. So just remember this if you want to screenshot. These two things help you decide whether the two lines are parallel or not. So now let's apply this to the question and figure out which one is parallel. So the equation that they give us is here, and we'll first check the first one, 5y equals 3x minus 6. So someone might say, okay, so 3x, same slope, it's parallel. But we need to make sure if the y-intercept is the same. So someone's like, oh no, -6, -6, they're the same line. That's not exactly true either, because here we have 5y, and here we have just y. So we need to have it in the same form to be able to evaluate whether or not it's parallel or the same or whatever. So let's take the equation 5y equals 3x minus 6 and simplify it, getting y alone to equal 3 over 5x minus 6 over 5. Now we can see that the slopes aren't the same, so we shouldn't even bother checking if the y-intercepts are the same or not. So A here is not an answer. So we can cross that off. Second one, 2y equals 6x minus 12. So first thing we're going to do is simplify to get y. Y equals 6/2. That's 3x, -6. So some people can say, okay, -3, we got the same slope, but we have the same y-intercept, meaning these are the same line. They're not parallel lines. So this is also not the answer. So on the SAT, you're not going to check the last one. Just going to run with it and circle C. But let's just prove that this is indeed parallel to the one they gave us. So 3y equals 9x minus 5. Here we can simplify, getting y alone to equal 3x minus 5 over 3. So here we found that the two rules applied and make them parallel because the slopes are the same and the y-intercepts are different. So this line is parallel to this line, making C the correct answer. They may also ask you which linear equation is the same instead of parallel, and in this case we're going to go with the one that has the exact same equation as this. And since we already solved the exact same question, or like the same examples for a different question, we already knew that this can simplify to the same equations. So just wanted to run this by real quick to make sure you guys understand that 3x minus 6. They may ask you for the same one, and in this scenario, you're going to try to get one that is exactly the same. So we knew B is the correct answer because same slope, same y-intercept, just as a question, so this is correct answer. On the same format as the other question, they may also ask which linear equation is perpendicular to, and then give you a linear equation. So just as parallel, there are conditions to figure out whether or not a line is perpendicular to another one, and these conditions are that the slope, so here the slope is 2, right? So the slope of a perpendicular line would have to be the inverse of this, meaning 1 over 2, and the opposite sign, so -1 over 2. So for two lines to be perpendicular, the slope has to be inverted, and then then it has to take the opposite sign as the first one. So this slope and this slope will make a two perpendicular lines. Now you may ask, what about the y-intercept? That doesn't really matter because let's say on the graph we have here this, and this is perpendicular, this and this is perpendicular. Like, okay, if I drew it right. Perpendicular, it doesn't really matter where the y-intercept is, but as long as it follows this rule that we mentioned before. And on a graph, this can be shown like, say, 2 would look something like this, and then -1/2 would look something like this. You know, like it perfectly lines up to be perpendicular. This has to be negative so it can go down. This has to be positive so it can go up. So this is just the rule to memorize to be able to determine whether or not something is perpendicular. And now to apply this to the question, we are going to focus on the slope. Let's check the first one, y equals 2x -3. So this has the same slope. So this cannot be an option. So we're looking for, again, the inverse with negative sign. So this is the slope we need. Let's check b. 2y, we need it to be in this form to be able to determine. So 2y equals 8 plus x, plus 8. And we're going to divide. Y equals 1/2x plus 4. Now this is very similar to this. This is inverted, but it is not perpendicular because the sign is not negative. If we were to draw this on a graph, the original one here would be like this, and this one would look something like would look something like this, where they're both positive, they're both going up in that direction. So they can't be perpendicular. It needs to be both inverted and positive. Negative for it to be perpendicular to this one. So this is not the option. Obviously C is going to be the option, but let's just prove it real quick. So -2y equals x minus 6. Divide by -2. This will be y equals -1/2x. So yes, the perpendicular slope is here, and then just finish it up, -3. So we found that the slope is perpendicular, making these two lines perpendicular. So this is the correct answer. So on the SAT, they ask a lot of word problems. So this is a good way to make sure we understood the lesson and make sure we're ready to answer any word problems related to this lesson. So this question says, in 2018, Company Z sold 685 products. Each year they sold 8 more products. Let T be the year since 2018 and write the equation for the total products they sold. So here they told us that they originally had this much without any years passing by. Each year they sold 8 more. So this is the rate that they sold, 8 more products. More. Let T be the year since 2018 and write the equation. So since we know that they originally sold, so say y, let's write the equation in this form. Y equals, what was the slope or the rate of change? We know that it's 8 because each year it would grow by 8. So that's the rate of change. So 8 t every year. So we're going to put t as a variable. So if there was 1 year past, it would be 8. But that's not true. They didn't just sell 8. They sold 8 over the original 685 that they sold before any years passing by. So we're going to say 8t plus 685. This would be the correct linear equation to represent this situation.